Okay guys, I'm going to continue quickly going over section 5-3. There was a couple of examples left, but I didn't want to crowd you with much. So I'm going to throw one more example at you, and it's called multiplying conjugates. But before we do that, I want to actually explain to you what conjugates are. Conjugates are any types of expressions of this type, in which you have a plus b, for example, and then you have the same two variables involved, the exact same variables, but with a different sign. In this case, we have the same thing, a square root of a and square root of b, square root of a and square root of b with different signs. It doesn't matter which one comes first, as long as the signs are different. So the next example actually involves multiplying conjugates. Let's say that I go ahead and tell you to multiply the following expression. Square root of a plus square root of b times square root of a minus square root of b. And I'm not liking that yellow. We're going to use the technique that we used in the previous problem, which was to multiply this first term times everybody. So we're going to do it like so. So we have square root of a times square root of a. Now we have a positive times a negative is going to give me a negative square root of a times square root of b. And I'm done with this guy. So I'm going to proceed to multiply the square root of b times the square root of a, and the square root of b times the negative square root of b. So I'm going to have a positive square root of b times the square root of a, and positive times a negative is a negative, and I'm going to have a negative square root of b times square root of b. So let's go ahead and see what we have next. Remember that since they have the same index, I can just go ahead and combine them under the same radical, and a times a is a squared minus, again we have the same index, so I can just say a b. Here again we have the same index. Notice that the product inside would be BA, but it makes no difference if I actually put AB, just to make it look like this one. And then finally we have a minus, same index here, and b times b is actually going to give me b squared. So it gives, this leaves a couple of things to simplify, which are going to be this one right here and this one right here. And we know that this exponent cancels out with the index, and I have a minus, again this cancels out with the index, and this is my final answer. And as you can tell, multiplying conjugates gets rid of the radicals, and this is going to come in handy in the next example. With rationalizing a binomial denominator. Remember that rationalizing is the process by which we get rid of unwanted radicals. So we're going to rationalize the denominator, and notice that in the denominator this time we have a binomial because we have 1 and 2 terms. So the question comes, how do we get rid of of those radicals, because now we have 2. But luckily in the previous example, and this should be actually example 8, I think. Just number it accordingly, please. In the previous example, we learned that there's an easy way to cancel out radicals, and that's by multiplying it times the conjugate. So I'm going to take this problem over here. And I already know from the previous example that if I multiply this denominator times its conjugate, and remember what I do to the denominator I have to do on the top, because I'm essentially multiplying by 1, right? So this all should be 1. And a common question is, if this is plus, should this be plus? Yes, because remember, you want these to be identical. You want the numerator and the denominator to be exactly the same so that you can divide them out and get 1. I already know that if I multiply these out, because these and these are conjugates, they're going to cancel out. I'm going to get rid of the radicals. But let's go ahead and work out the math and see what happens. This becomes kind of a distributive property in which I'm going to multiply 3 square root of 2 times square root of 5 plus square root of 2. And this over here becomes a product of binomials. So I'm going to use a different color here. 3 square root of 2 times square root of 5 plus, and I'm taking longer than I want to show you every step. 3 square root of 2 times square root of 2. Now I'm going to do the process from the last problem. And I'm going to have square root of 5 times square root of 5. Positive times a positive, it's a positive. So I'm going to have square root of 5 times square root of 2. Now I'm going to proceed and do the negative square root of 2. So now I'm going to have negative square root of 2 times positive square root of 5. And I'm going to have negative square root of 2 times negative square root of 2. So let's go ahead and work this out. Here, remember, I can combine, because I have the same index, I can just go ahead and say this square root of 10, because I multiply the numbers inside the roots. And now I'm going to have 3 square root of 4, which we'll be able to simplify in a minute. Same thing here, square root of 25 plus square root of 10 minus square root of 10. This is minus square root of 10, and then I'm going to have negative square root of 4, because I combined the product under the radical. So let's see what we can do here. This is going to go ahead and turn into 3 square root of 10. There's nothing I can do there, but this 4, the square root of 4 is just a 2. So I go ahead and say it's 6, because 3 times 2 is 6. And then this turns into a 5, because the square root of 25 is 5, and this just cancels out. So 5 minus 2. And then I actually see a couple of things we can factor out. But I'm going to just say that these would be an acceptable answer. But remember that you can divide by 3 here and divide by 3 here. So a more complete answer would be square root of 10 plus 2. Okay, but I would accept this as well.